I'm Anil Kumar. Here is a challenge question on midpoint of line segments. The question is, line segment with length of square root 72 has midpoint minus 3, minus 4. Determine the possible coordinates of the endpoint of the segment. So that's a very interesting question. We are given the midpoint and the length of the line segment. We need to find the endpoints of the line segment. Clearly, there could be many possibilities. Now, in one of the videos, I have used an approach of finding simultaneous equations and solving them. Here, I will use a different approach altogether. So what we will do here is, we'll consider a circle. And the segment we'll consider as the diameter of the circle. So let me just sketch one like this. So we are considering diameter of the circle as the segment. Now what we are given here is the midpoint. So we'll consider midpoint to be minus 3, minus 4 as given to us. And the length of this segment is square root of 72. Clearly, the length of the radius for us should be half of this length, right? So here we can write r is equals to half of square root of 72, right? So that becomes the radius. Now what is the equation of a circle where the center is minus 3, minus 4 with a radius of half of 72 square root? The equation is x minus, so general equation is x minus p whole square plus y minus q whole square equals to r square. So this is the general equation where p and q are coordinates of the center. So in our case, p, q are given to us as equal to minus 3, minus 4, and r is given to us as half of square root of 72, right? So radius is half of diameter. Let us substitute these values here. So we get x plus 3, since it is minus and minus, plus 3 whole square plus y plus 4 whole square equals to half of square root 72 whole square. So that becomes the equation which we should solve. Now the right side here is 72 divided by 4, which is, you can use the calculator. Half of 72 is 36, half of 36 is 18. So you can write this as 18 also. So basically we have an equation x plus 3 whole square plus y plus 4 whole square equals to 18. So we have this equation x plus 3 whole square plus y plus 4 whole square equals to 18. Now when we say that the radius is half of square root of 7, let's get an idea how much it is. So we'll do, let's say we can do square root of 72 is equal to, and we'll divide this by 2 and then write it in decimals, 4.2, right? So that is approximately, radius is 4.2. So that means slightly more than 4. So if I move 4 units to the right, I will be at x equals to 0. That means 0, x equals to 0 is a valid point, correct? So x equals to 0 will be, let's say somewhere here, kind of like this. So at x equals to 0, we can get two values of y, correct? On the circle, correct? Okay. So what we will do now here is, we'll substitute and say let x equals to 0. So we are taking one value of x, because now if x is 0, the diameter will be kind of like this. Now we are considering this line. Do you get the idea? Or we are considering another line which is kind of like this. Any of these two lines, right? So here we are saying x value is 0. So if I substitute 0 here, I get 3 square plus y plus 4 whole square equals to 18. So we have only one variable which we can find. So 3 square is 9. Taking it on the right side, we get y plus 4 whole square equals to 18 minus 9, which is 9, right? And when we square root, we get y plus 4 equals to square root of 9. Whenever you square root, you should do plus and minus. So that gives you plus 3 and minus 3 as two possible answers. So using these two, we can find the value of y. Okay? So one of the value of y will be 3 minus 4. The other one will be y equals to minus 3 minus 4. 3 minus 4 gives us minus 4, minus 1, and minus 3 minus 4 gives us minus 7. So we get 2 points here. One of them is 0, let us say this is minus 1, and this point will be 0 minus 7, right? So these are 2 points on this particular circle. Now to find the other points, we can work with first point and then find the other point of the diameter. That's the whole idea, right? Line segment with length of 72 has midpoint this. So this line segment is also the diameter of the circle. So it will have the same length as the previous diameter. We already found one of the points. We can find the other one. That is what we're trying to say, right? So what we have here is, let's say we call this point as A, and we need to find a point B here. So we know coordinates of point A are 0, minus 1. Midpoint, let's call this as M, is minus 3, minus 4. And we need to find B. So let B be x, y, right? To find x and y, we can use the midpoint formula. So we know x plus 0 divided by 2 should be minus 3, right? So x plus 0 divided by 2 should be equal to the x value of the center, which is minus 3. That gives us x as minus 6. Similarly, we can find the y coordinate. Y plus the y value, which is minus 1 divided by 2, should be equal to the y center point value, which is minus 4. And that gives you y equals to 2 times minus 4 is minus 8. And when you add 1 to it, you get minus 7. So we get the other points coordinates as x is equals to minus 6, y is equals to minus 7, right? So that is the point B for us. And we have already found A, which is 0, minus 1. So these are the two midpoints for our segment, which we just calculated. You can actually do calculations with the other points. Let's say we call this as P. You know P is 0, minus 7. Use P, the midpoint M, and find Q. So you'll find another segment with length of square root 72 and midpoint minus 3, minus 4. Likewise, you know, in a circle, there are infinite number of diameters, and so you can find so many segments with the help of this example. I'm Anil Kumar, and I hope the concept is clear to you. Those one of you who do not understand this formula can actually adopt the method which I have used in another video. Link for the same is being provided to you. Thank you and all the best.